Good afternoon, class. Today we are going to look at the continuation of light energy. Remember from the previous sessions of class, we talked about light energy and we looked at we looked at the properties of light. We looked at the various sources of light, artificial sources of light, and then the natural sources of light. I know you know them already. Today we are going to continue from where we ended in the last visual class that we had during the third term. If you have your textbook, you can look at pages 185 to pages 190. That is where this lesson is going to start from. In the last session, we looked at ray and a beam of light. Let's have a recap of what we did before we ended the last visual class that we had. We talked about a ray and a beam of light. We said a ray of light is the direction or the path taken by a light, and it is represented by a line with an arrow on it, as shown in the diagram over here. A beam of light is also a stream of light energy, or it is a collection of light rays traveling in a specific direction. Or a beam of light may be parallel, convergent, or divergent. Let's look at the parallel beam of light. We said it is a beam of light, a parallel beam of light is a stream of parallel light rays, which is shown in the diagram in this slide. And a convergent beam of light is also a collection of light rays which appear to come from different directions and meet at a common point. The diagram is what is over there. And a divergent beam of light is a collection of light rays which appear to come from a common point or a common source, also shown and then distributed. Remember, I told you the car headlights. I use a car headlights as an example, that there are some, if you have the low, you put the low headlight on, it's just, you can see just a few meters ahead of you. If it is convergent, you will see that it will meet in a concave manner, and the divergence comes in when the high light is on, especially when you are driving on a highway in the dark. When you give up the highlights, we have the divergence, which the rays can pass to the both left and right of the road, so that you can see in case an animal or somebody want to cross far ahead of you, you'll be able to notice and then skip or not drive in. Today we are going to look at the pinhole camera. Some of you might have read it already. We are going to discuss pinhole camera and look at how the rays of light traveling in a straight line. I think we have done that also. The rectilinear propagation of light, how the pinhole camera works with light rays of an object getting into the pinhole and forming an image inside that box. We shall also talk about shadows, how shadows are formed, and then how eclipses are formed. All these attest to the fact that light travels in a straight line. Now let's look at the pinhole camera. The pinhole camera is a simple camera without a lens, but with a tiny hole called a pinhole on one side of the box. Light from a scene or an object through the hole and project an inverted image. When I say something is inverted, it means it is turned upside down. An inverted image on the opposite side of the box, inside of it. So it works on the principle that light travels in a straight line. I hope you remember that property of light, where we talked about the rectilinear propagation of light. If you go on the site, the video is still there, or the pictures are there for you to see. So this is how the pinhole camera looks like. You can see an object in front of the box. The rays of light from the object passes through the pinhole where the arrow is pointing. Inside the other side of the pinhole camera, you will see that the image is turned upside down. That is one property of the pinhole camera. Images that are formed on the screen inside of it is turned upside down, or in other words, it is capsized. That is what you are seeing over there. Another example of the pinhole camera is what you are seeing on the screen. The sharpened pencil, light rays passes through it, light rays passes on it through the pinhole, and the image formed over there is turned upside down. Let's look at how the pinhole camera works. Now, light rays from various parts of an object placed in front of the pinhole camera travels in a straight line through the pinhole to form several tiny patches on the screen inside of it. So these patches combine to form a real and an inverted image of the same color as the object being in front of the pinhole camera. Now, it forms on a screen. Images formed on screens are real images. For example, when an image is formed, you take your phone and you snap a picture of yourself. You will see that the image is real because the phone has a screen on which the image is being formed. When you show a mirror to the sun and reflect the rays onto the wall, it's form an image. That is a real image. The wall now becomes what? A screen. So you realize that these patches of these tiny patches combine to form a real and inverted image of the same color as the object. Look at the L image over there. It turns upside down to form an image inside the pinhole camera, which looks like 7 instead of L. Let's look at some of the characteristics of images formed by a pinhole camera. As I said, the image is diminished. When we say something is diminished, it means that it becomes smaller in size than the objects. That is, its size is reduced. The image is inverted. That is, the image is turned upside down, and the image is also real. That is, the image can be formed on a screen. Now, after the characteristics of the image formed by a pinhole camera, if you check your textbook, you see that there are other notes below that. Now, one thing that happens is that now if you want the image to be bigger, there is something that you can do. If you want the image to be smaller, there is something that you can do. So looking into your textbook, you realize that there are some statements there. One says that the image is bigger in the pinhole camera. The image formed in the pinhole camera may be bigger if the object is brought closer to the pinhole. That is one. The image formed inside the pinhole will be smaller when the object is far away from the pinhole camera. That is, when the object distance is shorter than the image distance, the image becomes what? Big. When the image distance is longer than the object distance, the image is what? Big. That's the opposite way around. When the object is placed farther away from the pinhole camera, the image formed is going to be small. That is, the object's distance. When the object is placed far away from the pinhole camera, that's what we call the object distance. The object distance becomes longer than the image distance. Therefore, the image will be small inside the pinhole camera. If the object is brought closer to the pinhole camera, it means that the object distance is small, and therefore the image will be bigger inside the pinhole camera. Now, the image size can be the same as the object size when the object distance and the image distance are the same. That is, if the image distance is, let's say, 2 centimeters from the pinhole, and if the object distance is, let's say, 2 centimeters from the pinhole, and the image formed inside the box is also 2 centimeters from the pinhole inside, then the size of the objects will be the same as the size of the image, or the image size will be the same as what? The object size. Read further to get to understand what I am saying. So I'll put a video of the pinhole camera on the site, how the pinhole camera is made. I'll put a video on the site. I'm not including it over here, so that you download and then watch how it is constructed later on. Now let's look at shadows. I hope everyone has seen a shadow before, or a shadow of yourself. When light rays it's blocked by an opaque object. An opaque object, you know from the beginning of light energy that it is a opaque object is an object which does not allow light to pass through. When the sun is vertically overhead, like when it's 12 p.m., that the sun is vertically overhead, and you seem to stand on your image, on your shadow. When it's getting to about 1 p.m., then your shadow is cast ahead of you, or sometimes the position that you stand will determine your shadow, the shadow of yourself. Now, if you look at the girl standing in the image over here, you realize that the rays of the sun is at the back, and so it has cast a shadow ahead of her. A shadow is just a dark area or shape produced by a body coming between rays of light and the surface. So in the image that you are seeing over here, the surface is the ground. The surface is the ground, and the shadow of the girl is cast on the ground. So the light, the objects that has come between, or the body that has come between the rays of light and the surface, is a girl. Human beings are opaque. Light cannot pass through us. We cannot see through ourselves. So the diagram showing the shadow of the girl. How are shadows formed? Shadows are formed when light is blocked by an opaque object. if an opaque object is placed in the path of light rays coming from a source, a dark region is formed called a shadow or the shadow. There are different types of shadows. The types of shadows that is formed depends on the size and position of the light source that the opaque object is blocking. So let's look at the different types of uh, shadow formation. Formation of shadow from a point source of light. When we talk about a point source of light, we are talking about a small source of light. For example, a point source of light means a small source of light. The shadow formed by a point source of light is uniformly and totally dark with a sharp outline. I will show you the image right now. This is called umbra, the total darkness or the total dark area formed when a point source of light is blocked by an opaque object. Is called umbra, that is total shadow. A point source of light can be formed by placing an electric bulb or a lighter candle in a box or behind a cardboard that has a small hole in it. Now the diagram below is an illustration of how the point source of light forms the umbra. Now let's look at it. This is the point source of light. A lighted candle behind the cardboard over here. That is, the cardboard has a small hole in it. You see the small hole. Now light rays from the lighted candle passes through this small hole, which is called the point. A source of light from this hole is very small. This is the opaque object placed in the path of the light rays. You will see that the opaque object blocks all the light rays and casts its shadow on the screen. So the darker part over here, the one you see the pointer on, is what they call the total dark area, which is called umbra. I hope you are seeing it. This is the opaque object, this is the hole, the small hole, and this is the image or the shadow formed by the object that has blocked the source of light. That is a point source of light. Let's go to the next slide. Let's look at formation of shadow from an extended source of light. When we say extended source of light, we mean a large source of light. For example, a light in your room is extended because it extends to see every part of the room. Now, if an extended light source is used, the shadow form can be seen to be surrounded by a partial shadow, which is known as penumbra. Penumbra is a shadow formed by an opaque object between an external source of light and a screen. So an external source of light can also be formed by placing an electric bulb or a lighted candle in a box or behind a cardboard with a wider hole in it. This time around, the hole will not become small like what we saw in the point source of light. Let's look at it. Here, the lighted candle has no cardboard behind it, or it has not been placed in any box, so all the light rays can be seen. Now, the opaque object blocks the light source to its sides. You see that some of the rays are passing over the opaque objects. That is from Q to E, and then from P to I think F down here. Now, two different shadows are formed. We have the darker parts, which is what? Umbra. This is where the opaque object has blocked the source of light, and it forms a dark screen on a dark area on the screen, which is called the umbra. And then the partial shadow formed is what they call the penumbra, as discussed in the formation of the point source of light, shadow from the point source of light. I hope you get what I am saying. Now, formation of shadows from an external source of light, you see that the region of the umbra does not receive light from the source, while the region of the penumbra receives some amount of light from the source. Let's go back to the diagram. You can also refer to the diagram in your textbook. If you look at your textbook, you see that the image, the shadow formed by a point source of light and that of external source of light are there. Read and observe the image. So let's look at this one again. Since the slide is not going, but that is it. So the region of the umbra does not receive light from the source because it has absorbed part of it and has cast the shadow on the screen. Now, let's look at how eclipses are formed. Formation of eclipse. What is an eclipse? An eclipse occurs when light rays from the sun is cut off from reaching either the surface of the earth or the surface of the moon. As we may already know, there are two types of eclipse. We have eclipse of the sun, which is called solar eclipse, and then eclipse of the moon, which is called lunar eclipse. Now, eclipse of the sun occurs when the moon comes between the earth and the sun, and the moon blocks the rays of the sun from reaching the earth. What are some of the characteristics that we see? The moon's shadow is cast over the earth by the sun. The sun and the moon and the earth must all lie on the same plane or on the same line for eclipse of the sun to occur. Eclipse of the sun usually occurs during the day, and it occurs less frequently as compared to that of the lunar eclipse. And during this type of eclipse, some portions of the earth experience total darkness, what they call the umbra, whilst other portions also experience partial darkness, penumbra. A diagram in the book explains what I am saying. This is an image showing how eclipse of the sun is formed. This is the moon, which blocks the rays of the sun from reaching this part of the earth, and then this is the darker region, and which is called the umbra, and this is the partial shadow, which is called the penumbra. In your textbook, you realize that some alphabets have been used to label A, B, C, D, E. People who find themselves in A and then E experience no eclipse. Those in the C column experience total darkness, and those in the B and then D experience partial darkness. Refer to your notes and observe what I am saying. And then the last part of the lesson is eclipse of the moon. This type of eclipse occurs when the earth comes between the sun and the moon, and the shadow of the earth is cast over the moon by the sun. Eclipse of the moon occurs during the night. It also happens more frequently as compared to that of eclipse of the sun. This is a diagram showing how eclipse of the moon occurs. The earth, which comes between the sun and the and the moon. So over here, the shadow of the earth is cast over the whole surface of the moon. In fact, the moon is absorbed in the shadow of the earth. So there is what? Total darkness. This side will be the umbra, and this side will be the partial shadow, which is what? The penumbra. I hope you go through the textbook and find out some differences between eclipse of the moon and eclipse of the sun. Even from the lessons that we have just made, you can state some differences between eclipse of the moon and eclipse of the sun. There is an assignment that has been put there. You will do it, and then I'll mark it for you. Thank you very much. This is the end of today's lesson. Next week we will continue with reflection of lights. We shall also talk about refraction of lights, and then we will end the topic over there. Thank you very much.